quick summary. Given the orange points on the graph of y versus x, we construct a parabola that comes as close as possible on the average to the points. I've drawn a couple of parabolas that don't really do the job at all. This one, which isn't even a very good parabola, clearly misses this point by this much, and we're trying to get as close to the points in the vertical direction as possible. It misses this point by even more, because if the parabola continues, it's going to be down about here when it's below this point. And when we're here, who knows where this graph is going to be? That thing might be miles below us. Okay, so this is not a good parabola. Its vertex actually comes fairly close to the vertex of a good parabola, but that's about the only thing it has in common with the best possible parabola. Okay, this yellow curve does a much better job. It misses this point by this much, this point by this much, this point by this much, and it's never miles below the points that we started with. Okay, not that far from our data point, so it's definitely an improvement. And both of these parabolas, the green one and the yellow one, do have the characteristic that they open downward, and clearly the orange dots indicate a parabola that opens downward, if indeed this is going to be a parabola, and that's what we're assuming. Okay, so the purple graph, though, does a much better job. Now, I drew that by hand, and my arm was kind of in the way, so I went a little bit high. If this purple graph was lowered about that much, it would do a really good job of coming close to those points. Now, the one thing I don't do is I don't come along here just try to go through all the points. If I did, I'd have a little bump on the graph between here and here, and that's not what we do. Okay, we don't try to hit the data points. We try to get as close as possible on the average. Okay, so there's our parabola, and that's the one we're going to base the graph on. And I note that the axis of symmetry of that parabola, well, first we find the vertex, the high point. Our axis of symmetry goes through that point. That's going to be at about x equals 0.7. The vertex, I estimate then to be at 0.7, 1.5 on the scale of this graph. Now, we want to find our function y equals a times x minus h quantity squared plus k that represents this approximate graph. Okay, so what do we do? Well, our vertex gives us the coordinates of our h and k. That's because, remember, that this represents what we get if we start with the y equals x squared parabola, shifted h units in the x direction and k units in the y direction. Well, if I shift 8 units in the x direction, the vertex, which was here, will go over to here, and then if I shift k units in the y direction, it'll come up here. Okay, that's a shift of 1.5 in the y direction, so k is 1.5, and it's a shift of 0.7 in the x direction, so h is 0.7. Now, I went into a little more detail in the original explanation. You can look at the original video to see that explanation, or you can just read it. We end up, though, if h is 0.7 and k is 1.5, with y equals a times x minus 0.7 quantity squared plus 1.5. We still have to determine a. We do that by estimating the coordinates of any point on our curve, okay, on the graph, the purple graph that we drew. We don't use a data point. Notice that this graph doesn't exactly go through any data point anyway. Now, again, the graph is a little bit high, so if it was a little bit lower, it might appear to go through a data point, or one or more data points. The point I'm going to use, simple point, is the point where that purple graph crosses the y-axis, the y-intercept, and I estimate that to be at 0, 1.23. So, we need to find a. We're going to use this point And all we have to do is plug the coordinates of this point in here, and we're going to be able to solve for the value of a that matches up this point with everything we already know about the parabola, which is basically what the vertex is. Okay, so when we do that, we get the equation 1.23, that being our y value of this point, equals a times 0 minus 0.7 squared, 0 being the x coordinate of that point, plus 1.5. Having done that, the rest is quite simple. We just solve this equation. I'm not going to point out the details of solving the equation. You can solve it yourself. I believe you get a equals negative 0.55 to a couple of significant figures. So that our model now, since we've determined that a is negative 0.55, we can replace this a with negative 0.55, and our model is y equals negative 0.5 times the quantity x minus 0.7 squared plus 1.5.